make that up. We assume dark energy exists because we see that the universe is not only expanding, but that expansion is accelerating. And we have no way to justify that based on the physics we know. And rather than say the physics we know is probably incomplete then, or our understanding of reality probably isn't complete then. Instead of saying that, we say, oh, there must be this dark energy that makes it do that. You see? So what's going on there is that rather than looking for a more general physics that can explain that idea, that fact that we are expanding, with acceleration, instead of looking for a better, more complete physics, we take the limited physics we've got and make up stuff in order to make the equations work. All right, well, here's all this dark energy. Now that's why the universe expands. So look at that process. You have a phenomena that you see, like dark energy, and then you make something up to explain it, and then you name that stuff you make up. Oh, it's dark energy, and here are its properties. So how do these things that we observe actually happen? They are modeled in a virtual reality with equations, very similar equations to the very ones that we find when we make up models that are somewhat accurate. Okay, so let's talk about our elf. And our elf is in the world of Warcraft. And in the world of Warcraft, you have things like rivers, streams, and cliffs, and trees, and rocks, and buildings, and other people. Okay, now, an elf, little elf scientist here, he takes this rock and he drops it off the edge of a cliff. And he says, oh, everything goes down. And being a bright little elf, he says, gravity. There must be a thing called gravity here. And why does that happen? Well, it looks like all masses attract each other. Okay, now we got a little physicist elf who's decided that his realm has gravity and that all masses attract each other. Okay, it's sort of like what we did back when we came up with that same idea, masses attract each other. Okay, so we have that. What's really going on? What's really going on is it's a virtual reality. There are equations written that say when something has no support and it's heavier than air, it falls. And if you throw it, it goes on a parabolic trajectory because it has this constant acceleration toward the center. That's the mass attracting mass. So it's being modeled that way. The rendering engine that renders it has the equations in it that make it act that way. But you have rules. And what are our rules? They're called physics, right? It's all the understandings that we have. Now, we have gravity here. And you know that masses attract each other is a pretty good model. But it doesn't do well if you're talking about relativistic things. So then we make up another model. We say, all right, it's not masses attracting each other. It's that space-time is a fabric of space-time is warped by mass. And gravity is just smaller things rolling downhill into that warped space-time hole that, or valley that's being made by the heavier thing. Oh, okay. Now that works better if we're talking about relativistic things. It's just another model. Is that really true? Is there really a fabric of space-time that warps? Of course not. There's just equations that render things as if that were true. Equations that rendered things as if masses attracted each other. So when masses attracting each other was the appropriate answer that's satisfied, then that's what you get. That's what you can measure. When you can measure more subtle things like relativistic effects that you don't measure just every day, that takes some very special kinds of measurements, then you have a different result. It's all in the basic rule set that helped evolve this reality, this virtual reality. So think about how the virtual reality started. It started with initial conditions and a rule set, and then it just was let go so that the initial conditions could change according to the rule set. And they did. And now here we are. Okay, that created universe, that created the planet, that created the sun, that created the cells, the microbes, the trees, the bushes, and lizards and frogs and fish and us. All got created out of that evolution according to that rule set. Okay. So it has all the equations necessary to project what evolved out of that rule set. It's the rule set are the equations. You see? So it has the equations for everything that has happened here because it had to describe it. That is the rule set. What does science do? We dig out rules. But we're digging out rules that enable this virtual reality to be rendered, not rules that describe physical things that are happening. That's the difference between being a materialist or seeing that this is a virtual reality. One, you say where the rules are how material things interact with each other. The other is saying the rules express how this virtual reality is rendered. Now, you take those two ideas, and since you live here, you'd feel like, well, the one that's materialist actually sounds better because, you know, material things interacting with each other. I get that. That's more reasonable. But when you take that reasonable viewpoint, there's a lot of things you can't explain. You can't explain. Where does time come from? Where does charge come from? Where does mass come from? You can't explain any of those. Why shouldn't a double slit experiment particles distribute themselves in an interference pattern when they're only coming one particle at a time? No answer for any of those things. So you realize that that materialist view is just wrong. You can't model reality as a little, an electron, as a little chunk of mass with a charge. It does not work. If the particle physicists tried to do that, they would not be able to get the right answer or what happens when they smash particles together in big atom smashing machines. They'd always be wrong. They could never figure out what happens. But they model it as a point with attributes. Now they can get something. There is no particle, you see? So even though that materialist viewpoint seems more obvious, more obviously true, it runs into problems, things it just cannot bring answers to. It can't say, where do the initial conditions and the rule set come from that started this? It can't deal with that either. Can't deal with that beginning. It can't deal with purpose. What's the purpose here? What's the point? It can't deal with a lot of things. So there's a lot of big questions, both in philosophy and in physics, that just are unanswered because the materialist viewpoint does not have the right answer. So it's not the better physics. It's not the bigger physics. It's a subset. Within this little picture, gravity works like this. Within this bigger picture, it works a little differently. Like the difference between Newtonian mechanics and quantum mechanics. Quantum mechanics is accurate within the subset to which it applies. You see, quantum physics applies to a larger subset, but still doesn't have all the answers. So what you look for is a bigger and bigger physics, a bigger and bigger viewpoint of physics. So physics sees the biggest viewpoint, and then it can explain everything. As long as it's only looking at a subset, we're only looking at things that are slower than this and heavier than that. All right, now Newtonian physics works really good, but it's limited. And so is quantum physics, limited. Can't explain a double slit experiment. You see, so is relativity, limited. Can't explain why C is a constant. So that's the point. You're looking for a more general physics. And this idea of virtual reality, this being a virtual reality, supplies that. So what would physics look like if it wasn't material-based? It would look very much the way it looks right now, because we'd say, from the viewpoint of the avatar, things work like this, because that would be inside the virtual reality. But it would also realize that there's a bigger viewpoint, and it would explain why individual particles rearrange themselves into interference patterns. It would explain that, and it would explain where time comes from and where charge comes from. It would explain those things. So now you have a more general physics, but you still have subsets of it. The subset called classical mechanics, Newtonian physics, that still works as applied to things inside the virtual reality. So it doesn't go away. It's not like the old physics disappears. You just realize that the old physics works within a certain subset of reality. It doesn't work as your reality. If your understanding and awareness of reality gets bigger and bigger, your materialist only works with this subset inside the virtual reality, and it only works in this subset just with things that aren't too fast and aren't too small.